This video is an introduction to how to write your data management plan. A data management plan is a document addressing requirements and practices for handling the project's data, source code, and documentation. It is a document that will develop as the project progresses, and the content will change to reflect current plans and practices, from applying for funding to collecting, analyzing, publishing, and archiving data, and finally ending the project. Your data management practices should address the concerns of your stakeholders, starting with your research group, funders, research community, and host institution, but also the concerns of human research subjects, publishers, the general public, and many others. The Swedish Research Council's template is based on 6 central aspects identified by Science Europe. The first being description of data being reused or produced by the project, followed by documentation and data quality standards and procedures, storage and backup to support the project, legal and ethical aspects to comply with regulations and ethical obligations, accessibility and long-term storage beyond the project's end date, and finally, responsibilities and resources required to implement the plan. We will take a look at each of the aspects with examples of questions to answer, starting with descriptions of data. That is, how data is acquired and what its characteristics are. If you are using data that existed before the project was initiated, you need to know where and under what conditions the datasets are available and how and when you will get access to them. When it comes to data that you will be producing or collecting, you should be able to describe what you will be collecting, if you're doing it by yourself or by contractors, and what instruments and methods you will use. Characteristics include type of data, such as numeric, textual, image, audio, video, and sequencing data. If you have a choice, the file formats and structures used to store the actual data could be selected based on community standards and data repositories in your discipline. But you may also need to store data specifically to support your software, instruments, and workflows. It's also useful to estimate the volume of data you will be working with, in number of samples and attributes, in versions and files, and in actual megabytes of storage, partly to figure out how to choose your storage and backup solutions. Looking at your documentation and data quality control measures, you should ask if there are community standards and conventions for metadata, describing your samples, measurements, annotations, etc. in a way that allows others to identify, locate, and discover them. What conventions will you use for naming, locating, and versioning files and documents in the project? What additional documentation would be necessary to reuse the data, such as lab reports, pipelines, transcripts, and README files or data dictionaries? Some aspects of your data capture and processing should probably be tracked, such as instrument settings and calibration, data capture protocols, or versions of software, pipelines, and outputs. You can also take measures to validate the integrity of the data itself, such as repeated measurements, peer review, and assuring conformance to expected values and ranges. You also need to consider how to store and protect your data at different stages of your project. You might have several different storage or processing locations for data collection, analysis, reporting, code, transfers, etc. You need strategies for backup and data recovery to minimize risks of data loss. How would you, for example, handle a stolen laptop or accidentally changing or deleting a file? There might also be technical requirements, such as specific software versions or systems that you need to access or process the data. And some data will need a higher level of security, and classifying your information can be a step towards selecting suitable storage solutions. In some cases, you will need to put restrictions on who will have access to what data, and apply other data protection strategies, such as data encryption or digital signatures, to minimize risks of unwanted data disclosure or sabotage. Legal and ethical aspects will influence how you can handle data in your project. Personal data and other sensitive data can be subject to local and international law, such as GDPR and other regulations on confidential or copyrighted information. You may need to answer questions of ownership and responsibilities when sharing data across institutions, commercial entities, or national boundaries. And there may also be other legal limitations on processing or sharing data, such as the terms of contracts and licenses. Further limitations can be imposed based on what was included in an ethics application or informed consent, and there can be factors in a risk or impact assessment that would be addressed by your data management practices, such as anonymization or reducing the level of detail in your data before analyzing or sharing. Conventions for access and benefit sharing can also be a factor when deciding how to collect and where to share your data. Decisions on long-term access and storage will have consequences well beyond the project's end date. You will need to decide when and where to submit or deposit your data, opting for an embargo period or restricted access as appropriate. You also have to determine which data should be archived for record keeping at your institution and for how long these records should be kept. If software and source code is part of your project, you should also consider how to make it available and if you will aim to maintain it beyond the project. Make notes of where and how to find, access and cite the data, including which identifiers and locators to use, such as accession numbers or DOIs. Identify which file and data formats would be suitable for data sharing and archiving, including which actions you would have to take to convert them. Finally, adopt licensing that would enable and promote reuse and future collaborations. You should aim to make your data as findable and accessible as possible. The following is a simplified decision process to illustrate a few different types of repositories for data sharing. Starting with a dataset, ask yourself, does this contain personal or sensitive information? If the answer is yes, choose a restricted access repository. If no, the next question is there a suitable domain-specific repository? If yes, choose a domain-specific repository. If no, you should ask yourself, is there an institutional repository for your organization? If yes, choose the institutional repository, such as SciLifeLab Data Repository for SciLifeLab projects. If no, there are general data repositories such as Zenodo and others. The final part is to assign tasks and secure resources for executing the plan. That is, identifying activities, milestones, and responsibilities related to handling data in the project. Also consider coordinated activities in partner projects. Identify tasks and responsibilities that will remain after the project has ended. For example, name institutions or people responsible for long-term access and maintenance. You should also list budget items for documentation, storage, software, publishing fees, long-term access, and so on. And remember to reserve time for data management activities, such as preparing data for submitting an article. When creating your data management plan, plan for long-term access early on. Information on institutional and discipline-specific data sharing practices can inform many other decisions. Refer to established guidelines and procedures. You will find guidelines specific to your organization, specific guidelines for life sciences such as SciLifeLab's data guidelines and NBIS human data guidelines. There are also guidelines at the Swedish National Data Service. Use templates and tools provided by your organization or funder, or use SciLifeLab's Data Stewardship Wizard. Thank you for watching. Continue with the video on how to use SciLifeLab Data Stewardship Wizard. For questions, get in touch with your university's local data office or get in touch with us at SciLifeLab. SciLifeLab.se/data.